Hey y'all, this was Power. I am gonna do the review for Module 7 on this video. We'll do it during class tomorrow, right? And you can start working on it tonight. You can start working on it during class tomorrow. You can finish working on it afterwards. But the test is on Friday, so you should do it before that. All right, let's go. First, we're gonna find the volume and the surface area of the cylinder. The volume for a cylinder is the area of the bottom, so pi r squared, times the height. Here is the height, here is the radius. So here we're just going to do pi times 15 squared times 20. We're going to plug that into a calculator. I've got a calculator. Nice. So 3.14 times 15 squared times 20. Literally just plug that into the calculator, enter. I get 14,130. Kill it, right? The surface area of a cylinder it's the top area, pi r squared, plus the bottom area. So that means there's two pi r squareds. And then we're gonna add in the around part. The around part is 2 pi r times h. What we can think about this is we do the cylinder, or the circumference, just like a bunch of times. H times, for instance. Here for us, this is 2 times pi times 15 squared plus 2 times pi times 15 times 20. So again, we do 2 times 3.14 times 15 squared plus 2 times 3.14 times 15 times 20. Just plug it in your calculator. Bingo bongo. Feeling good. For your next one, we're going to do the volume and the surface area of a rectangular prism. The volume of a rectangular prism is length times width times height. The surface area is the top and the bottom, so length times width, and there's two of them. The front and the back, so if this is length, this is width, and this is height. The front and the back of this box are height times length, and there's two of them. Then we're going to add the left and the right side. This is also a height, right? So that's height times width, and there's a left and a right side. We have two of those. And then we can just plug in our numbers, right? This is 15 times 4 times 7. This one is 2 times 15 times 4 plus 2 times 7 times 15 plus 2 times 7 times 4. We just plug these in our calculator, right? 15 times 4 times 7. Nice. 420. Then we've got 2 times 15 times 4 plus 2 times 7 times 15 plus 2 times 7 times 4. Nice. 386. That's that for that. These first two are just knowing the equations, plug it in. And I might even give you these equations, to be honest. Then the third one, suppose you have a rectangular prism with dimensions that are 1/2 the size of those in B. So instead of in B, where's my mouse? Oh my god. Okay, here we go. Instead of 15 by 4 by 7, these ones are going to be 7.5 times 2 times 3.5. We could plug these into the equation, right? We could plug this length, this width, and this height into the equation. We could also say, if we're dividing the dimensions by 2, that's going to divide the surface area by 4, and that's going to divide the volume by 8. Here's why. If each of the length and the width and the height were divided by 2, overall, that's length and width and height divided by 8. And if area, which is generally, 2 variables, if each of these were divided by 2, that's the area divided by 4. Each of these would be divided by 4, which means the entire thing is divided by 4. So I'll take 420 over 8. 420 over 8 is 52.5. 52.5 is my volume. And then 386 divided by 4, 96.5 is my surface area. Again, we're definitely allowed to do it the slow way. We can do half of all of our dimensions, then plug it into the formula, but we don't have to. That's what our worksheet was about on whatever day that was, Tuesday. Nice. All right, this is the one everybody hates. But maybe you'll like it by the end. Probably not, though. But you'll definitely be able to do it. Let me move all this down. We're definitely going to need more space. Wow, messed that up. Here we go. Nice. Find the area and perimeter of the following stop sign, which is a regular octagon. Round answers to the nearest hundredth and use correct units. Here, they told us that the width was 40. And this is kind of like the one we did in classwork today, right? We did a hexagon in class today. We'll do a stop sign tomorrow during review. We're going to section these into 8 even triangles. I don't know why I'm not using the actual lines. Here we go. Nice. Beautiful and perfect. We already know that this height will be 20 and this height will be 20 because all the way around is 40 and that's half. So off to the side, I'm going to take one of these. Oh, wait, no, before we do that, we need to find this angle, like the angle in the top of all these triangles. The way to do that is we go all the way around the circle is 360. We've got 8 different triangles, so we'll divide it by 8. And we'll say that this top angle is 45. Now we'll take one of these triangles off to the side, draw it big so I can actually work with it. I know that this top angle is 45. I know that when I draw a line straight down, that height is 20. And then it makes a right angle. I know, let me do green again. I know that this altitude or this height, cut it in half. So each of these angles is 1/2 of 45. And in order to find the area and perimeter, I need to find the base of this triangle. I'm going to do this using trig. Drag this over here. Great. In order to find x, I know the angle, 22.5. I know the opposite side and the adjacent side, and opposite over adjacent, tangent. So I'll take the tangent of 22.5, set it equal to x over 20. Here. And now I'm going to use my calculator. I'm going to plug in tangent of 22.5. So tangent 22.5 equals, I got 0.414. Now to solve for x, I'm going to multiply by 20 on both sides. Canceling this, getting that x equals this times 20. Times 20 means x is 8.284. So 2. Nice. If this x is 8.28 and this x is the same thing, 8.28, that means the entire base of my triangle is 8.28 times 2, 16.56. My height is 20. They gave me that. And now that I know my base and my height of all my triangles, so base was 16.56 and height was 20, now I can find my area and my perimeter. The perimeter is just all the bases added together. That's a base, that's a base, that's a base. Right, there's 8 of these bases added together. So my area my perimeter is just 6 times the base. 6 times 16.56, 6 times 16.56 is 99.36. 99.36. This was in inches, so my perimeter is also in inches. The area is the area of this triangle. Oh, shoot. No, it's not times 6, y'all. It's times 8. What am I even saying? Perimeter is times 8 because there's 8 triangles. Get it together, Johnson. We'll do 8 times 16.56. That's the actual one. 132.48. Nice. Also inches. Yeah, here we want to multiply by how many triangles there are. And we cut this 8-sided shape into 8 triangles. So we're doing 8 times the base. Got there. Okay, and in the area, we find the area of each of these triangles, which is 1/2 times the base times the height. And then there's 8 triangles, so we multiply it times 8. So in our calculator, we'll do 1/2 times 16.56 times 20 times 8. So 1/2 times 16.56 times 20 times 8. And we'll get 16 times 20 times 4. Yeah, I guess that's right. 1324.8. Because this is area, it's inches squared. Hold on. Yeah. Cool. Next one, we're going to use the following equations. We're going to use that the area of a circle is pi r squared. Let's make that better. We're going to use that the circumference of a circle, circumference, is 2 times pi times the radius. We're going to use that the sector area is pi r squared times the angle in degrees divided by 360. We're going to use that the arc length, not the arc measure, the arc length is 2 pi r theta in degrees divided by 360. And these are things we should memorize. But for each of these, the only 2 variables are radius and theta. So r and theta. What I want to do is, for my picture, find r, for my picture, find theta, and then plug it into these equations. My radius here is 12. My theta is 105. And I can just plug this in. The length of the smaller arc is 2 times pi times 12 times 105 divided by 360. And I'm just going to plug that in. I'm going to plug in 2 times 3.14 times 12 times 105 divided by 360 and get 21.98 inches. Seems good. What's the area of the smaller sector? We're going to plug it into our sector area, right? This one's pi times the radius squared, so 12 squared, times 105 divided by 360. And that's exactly what I'm going to plug into my equation. 3.14 times 12 times 12 times 105 divided by 360. I'm going to get 131.88, and that'll be inches squared because it's an area. Length is just inches, area is inches squared. What's the area of the entire circle? That is pi r squared. Right, you can leave this as 144 pi, that's my preferred, or you can do 3.14 times 12 squared and get 3.14 times 12 squared and get 452.16. Area is inches squared. Okay, I'm back. This is the first time I'm editing a video to see if I can splice those two together because I got interrupted. We'll see how it goes. All right, we stop at the area. Let's go to the circumference. When we're working with the circumference, the equation is 2 pi r, which for us is 2 pi times 12, which means it's 24 pi. And that would be inches because the circumference is a length. If we wanted the decimal version, which I don't know why you would, but you're allowed, you would do 24 times pi and get 75.36 inches. Totally also an okay answer. Moving on. This question is basically the same thing, except they gave us radians as our angle at first, and we have to have degrees before we plug it into our equation. So over here, our radius is 4, and our theta is we need to change 4 pi over 3 into degrees. So over here, I'll change 4 pi over 3 into degrees. First, I'm going to use the unit conversion way. So if you're a ratio person, just ignore these next couple minutes. Unit conversion way is I have radians right now and I want to get rid of them. So I'll put 2 pi in the bottom. And I want them to be in terms of degrees, so I'll put 360 on top. Now I simply do this multiplication. I would do 4 times pi times 360 on the top, times pi times 360. And I would do 3 times 2 times pi on the bottom. I'm going to cancel the pi's to make sure nothing's wacky in my calculator for rounding. Then I'll do 4 times 360 divided by parentheses 3 times 2 and get 240. Pretty good. If we instead wanted to do the ratio way, right, 4 pi over 3, if we want to do ratios instead, I would put my 4 pi over 3 over 2 pi, because that's all the way around the circle in radians. I'd put x over 360, because I don't know the degrees, but I do know that all the way around is 360. And now I would cross multiply. I would get 4 pi times 360 over 3 on this side, and then I would get 2 pi x on this side. When I solve this, I am going to multiply both sides by 3 so that I don't have any fractions at all. We do 360 times 4. 360 times 4 is 1440. 1440 times pi equals 6x times pi, because 2 times 3 is 6. I'm again going to cancel the pi's, divide everything by 6 to get x alone. 1440 divided by 6 equals 240, which is good because that's what we got the other method. And certainly we want to do the same. All right, now that I've changed this into degrees, I can go ahead and plug these in my equations. My arc length is 2 times pi times the radius times my theta, or my angle, divided by 360. I'm going to do this in the calculator. I'm going to do 2 times 4 times 240 divided by 360. I guess I should times that by pi as well. Forgot that one. Gets 16.75 inches. Length is in inches. For area, I'm going to do pi times the radius squared times my angle over 360. I'm going to plug this in the calculator. We got pi times 4 squared times 240 divided by 360. Oh, I messed that up. 240 divided by 360. Yep, that's better. Area is inches squared. Control Z, inches squared. The area of the circle is pi r squared, which is 16 pi inches squared. Or if we really care, we can do 16 times 3.14 and get 50.24 inches squared. The circumference is 2 pi r, which is 8 pi inches. Circumference is just a length, so it's just inches. Or again, we can get the decimal version and get 25.12 inches as well. Oops. Amazing. All right, now we're going to convert degrees into radians and radians into degrees. We've done this before several times in the test, and we might do it again. Here's the plan. I'll do the first ones with the ratios, and I'll do the second ones with the unit conversions. For the ratios, our ratios are always 360 on the bottom and 2 pi on the bottom. If we've got degrees, we put our degrees above 360 and an x above radians, and then we cross multiply. Let me actually zoom out, give myself some more space. Nice. Okay, I put my degrees over the entire circle in degrees. I put my mystery in my entire circle in radians, and now I'll cross multiply. Hello.
You good?
Yeah, I'm good. I'm making a video, but you can come in. I don't mind. Okay. I'll cross multiply here. I'll do 2 times pi times 900 equals 360 times x. I'll then divide both sides by 360 so I can get my x by myself. And then I can do 900 times 2 is 1800 divided by 360 is 5. So this is 5 pi, because again, I did 2 times 900 over 360, got 5, and then left the pi. Or if I really wanted to, I could just plug this entire thing into the calculator, not just the non-pi part. So 2 times 3.14 times 900 divided by 360 and get 15.7. Either one of these works. And then if we want to convert the other way, our ratio is still 360 on the bottom, 2 pi on the bottom. But now if we know the radians, that's fine. We put the radians here, we put an x here, and then we still cross multiply. A lot of people like to change this into a decimal and like to change this into a decimal before we begin. So we'll do 15 times 3.14 divided by 4 and get 11.775. And then when we cross multiply, we get 6.28 times x equals 11.775 times 360, which is 4239. I'll divide both sides by 6.28. Divided by 6.28. And I'll get that my degrees are 675 degrees. That's the ratio method. The unit conversion method, and again, you only have to know one of these methods. The unit conversion method is saying, I've got 613 degrees. I no longer want degrees, so I'm going to divide by degrees and multiply times radians so that my degrees cancel and I have a radian as an answer. So this one would be 613 times 2 times pi divided by 360. And I'm just going to plug all of that into the calculator, right? So 613 times 2 times 3.14 divided by 360. And I'll get 10.69. And that's radians. Again, the thing we want to end up with is on the top, and the thing I want to get rid of is on the bottom. So here, I've got 7 pi over 18. The unit conversion way, I'm going to put 2 pi on the bottom and 360 on the top. I'm going to cancel the pi's. And then I'm going to plug 7 times 360 divided by 18 times 2 into a calculator. And I'm going to put parentheses around these because otherwise it's going to mess up. So 7 times 360, 360 divided by parentheses 18 times 2 equals 70 in degrees. Again, the reason we put degrees on top is because we don't have it and we want it, and we put radians in the bottom because we have it and we want to get rid of it. Yes. For these two, we're going to use trig and the Pythagorean theorem to solve for the missing side lengths of the following triangles. Okay, for this one, if we look at 30 as our angle, 22 is our hypotenuse, x is our opposite side, and y is our adjacent side. Right? We always want to say which one's our hypotenuse, which one's our opposite, and which one's our adjacent when we're doing trig. The other thing to remember about trig is that sine is opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So here, I'm going to solve for x first. I'm going to say that the sine of 30 degrees is the opposite, x, over the hypotenuse, which is 22. Now, I'm going to plug sine of 30 into a calculator. Sine of 30, we get 0.5. And to get x by itself, I'm going to multiply both sides by 22. These cancel. 22 times 0.5 is 11. And I figured out this side. To get my next side, I've got two options. I can either use the cosine of 30 equals y over 22 and solve for y that way, or I can say that 11 squared plus y squared has to be 22 squared by the Pythagorean theorem. So I get 121 plus y squared equals 22 times 22, which is 484. I'm going to subtract 121 from both sides and get 363. And then I'm going to square root both sides and get the square root of 363 is 19.05. So y is 19.05. And this would have given you the same thing. This would have also told you that y is 19.05. Great. We're about to do the same thing over here, right? We've got an angle. I need to figure out which one is my hypotenuse, which one is my opposite, and which one is my adjacent. I'm going to solve for x first. I know the opposite, I want the opposite, and I know the adjacent, so I'm going to use tangent. The tangent of 45 is x over 10. I plug in tangent of 45 into my calculator. I get 1. I say x definitely has to be 10 if I want x divided by 10 to equal 1. My x is 10. And now, to find y, I can either use sine or cosine, or I can do the Pythagorean theorem. I can say 10 squared plus 10 squared equals y squared. That's 100 plus 100 equals y squared. 200 equals y squared. And I would square root both sides to get y by itself. Whoa. 14.14. Nice. Okay, I think this is the last one. Last one. Nice. We're going to do some circle measurements. Where's my mouse? Let me pull this down a little bit. Ooh, I lost it. Okay, for this one, we're given a circle diagram, and I want to know a bunch of arcs, and I want to know a bunch of angles. Let's get started. The first thing we want to know is when we read the directions, we know that WX and VX, WY and VX are both diameters, which means C is the center of the circle. Cool. We want to know first, arc WX. The only thing we know about arc WX is that this pullback of WX, this angle WYX, is 30. When the pullback is 30, that means the actual arc is 60. We know that because the inscribed angle, or the pullback angle, is always half of the arc that it shares a start and a stop with. For measure of angle WCX, let's find where that is. WCX, we want to know this angle now. This is also sharing a start and a stop point with this angle, or with this arc 60. But instead of being an inscribed angle where it goes back to the side of the circle, this one goes to the center of the circle and is a central angle, which means it's the same as this arc. Okay, next one, YCX. YCX, we're looking for this measure. YCX is a linear pair with WCX, right? These two have to add up to 180 because they're right next to each other. So we do 180 minus 60 and get that this one is 120. Measure of arc XY. If we're looking at XY, which central angle does this arc share? Measure XY and the angle we just found are the exact same because it's the same as its central angle. Nice. Measure VCY, VCY. If we want to know this angle, this is going to be 60 because they're vertical angles. This is vertical with the red WCX. Cool. Arc VZ. This one's kind of tricky. If we want arc VZ, we first need to say, what is arc VY? Right? V to Y, we know because we know this angle, right? This is the central angle for arc VY. So this entire thing is 60, which means VZ plus ZY is 60, which means this has to be 40. And then the last one, VXZ. VXZ is this angle. This is an inscribed arc for 40, so it's going to be half of 40. Again, when I say inscribed arc for 40, I mean the 40 arc started at V and ended at Z, and this angle also started at V and ended at Z, but instead of being pulled to the central, like a central angle, it was pulled to an inscribed angle. It was pulled to the back of the circle. So it's half. Cool. That's the review. Y'all, this is what the test looks like. There's a couple of bonus questions, like extra credit questions on the test, but they're bonus, so it's going to be kind of a surprise on Friday. Tomorrow, we'll have all hour to work on this with your group, work on this with your friends. You can work on it tonight. You can work on it tomorrow night. You can come after school on Thursday. You can come before school on Thursday or Friday. Good luck.